doing these. I was like, I like got to like 10%. I was like, oh cool, I stopped for trying home. I mean, I don't know home from here, but so the idea is that whenever you're doing like the alpha, beta, like 1, 2, 1, 4, 1, whatever labeling, that is related to an anomeric carbon and then whatever carbon that it's binding to in terms of like another cyclic sugar or whatever. So this is kind of where I don't think he's gonna give us anything other than like hexose sugars. I don't think he's gonna do like stuff that's like crazy, but he could. But the idea is that you basically just have to count your carbons or whatever. So the anomeric carbon usually is either 1 or 2. So if it is a aldehyde, aldose sugar or whatever, it's always going to be 1. If it's a ketose sugar and you see this like CH2OH down off of the bottom of it, then this is technically 1 and this is 2. So that's all that really plays into in terms of what your anomeric carbon numbering is. Okay. Does that make sense? Mm-hmm. So the idea is that if it's beta or alpha, it's all based on the anomeric carbon.
So you said if it's
a ketose sugar, your anomeric carbon is going to be number 2. If it's an aldose sugar, so it doesn't have this little piece here, this little extra carbon here, it's an aldose sugar, then it doesn't have that, so then it's carbon 1. Which you think about whenever we did like our like Fisher to Hayworth or whatever, and like our like cyclizing and all that, like the aldose is like your carbon is always carbon 1 and you were just circling around to it, whereas the ketose, it was always carbon 2 and you were circling around to it, and you had to add in, you know, that first carbon here afterwards with like your aldose or whatever. So the idea is that for this one, if this is an aldose sugar, if this is an aldose sugar, so we'll say that this is carbon 1, so this doesn't exist since we're doing this in black, then we're saying that this is going to be beta 1 because it's going up, and then we have to look at our next sugar to get our other spot. So same thing, this is an aldose sugar because you don't see that other ketone group on there. So then this is 1, 2, 3, 4, 5, 6, and we're bound at 3. So then it's beta 1, 3. In terms of like which, it's just telling us which carbons are bound together. If we were to treat this as ketose sugar, where it has this extra piece on here, and we're looking at that being number 2, then this would be a beta 2, and then if this is this aldose sugar here, we would say beta 2, 3.
So the beta and alpha like is going to be like 1 or 2 basically, and then but the second number is what changes. I thought it was like alpha 6, and I'm like, yeah. Where's that?
Yeah, no, it's usually almost always going to be 1 or 2. There are instances like whenever like he's not having us learn like complex sugar structure, but there can be other ones. But for the purposes of what we are learning, it's literally just using 1 or 2, depending on if it's an aldose or a ketose. And I don't really expect him to do ketose sugars when he gives this to us on the test. I'm thinking he's going to use aldose sugars because he's going to try to not basically confuse people, because I know people are already confused, and he didn't spend very much time on this, and he said he really just wants it to be very surface level in terms of like what he's doing this, because you could get very in the weeds, and we don't want to do that.
He made the comment on this, we wouldn't have to go to like Fisher from this to like solve or something like that. I don't know what that means, but
to solve this part of it, I don't think you should have to go to like Fisher or anything like that, because it's just counting carbons for this part of it. He might say, you know, like we break it at like this bond or something like that, which means that this is this OH group, and he might have you take it and turn it into like Fisher projection or something like that. I could see him doing that, especially since he put that on his little like study guide that we have to be able to convert. But that's just knowing that this is, you know, like OH group or whatever, and then just being able to take the rest of your structure, like whatever direction your OH groups here are, knowing if they're right or left in terms of the fissure projection or whatever, and then just basically just flattening this out or whatever. But in terms of like the alpha, beta, whatever stuff, like this is all he's looking for in that regard. In terms of like where things can be numbered, I kind of threw some other things in here to kind of show you guys that you kind of have to make sure you're counting your carbons and looking at what the bonds look like. So for this one, this is pointing down. So what does that mean?
Alpha.
So it's alpha. And this isn't, I didn't draw it out as being a ketone or anything like that, so it's an aldose sugar. So what carbon is this?
1.
Okay, so then we have to figure out which carbon this is that it's bound to. With the idea that I intentionally drew this very sharp angle in here to give an idea of that there is a carbon right there.
See, this is where I get confused because
When you see it and it looks like really sharp angles like that, like if they draw it out like that on the like, and then you have your like ring structures, these are not carbons. When you do sugars, you have to make it a 90-degree angle to identify there being a carbon there. So like he has it on the amylopectin or whatever.
So is this considered or
No, no. So that's
Neither
not.
of these are.
Neither of those are, but the amylopectin one on the
This
top
one
there,
here is.
that one
These
is.
aren't, but that is.
Right. So the idea is if he has it drawn kind of like this, like those are not, and it could be like up or down. It could be, you know, where you like have like that or whatever. But if it's sharp angles, it's not one. The other way to identify it is that there are 2 of these sharp angles. There's only one of those sharp angles here.
You mean you would say that that's not a glycosidic bond? Yeah,
The sharp one.
the sharp
These?
is not a glycosidic bond.
Correct.
Those just aren't carbons. It's still bonding between 2 sugars. It's still a glycosidic bond.
They're
like
just
these.
like
It's just
sharp
there's not
like
extra
that
carbons
to
in
save
here,
space.
but this one there is.
So what do I need to know?
Like this and this one, those are not carbons on there.
Oh, yeah.
Yeah.
Is what he's saying.
I think it's to
Oh,
save
so
space.
I'm saying that this carbon is connected to this carbon, those aren't.
These aren't carbons
Gotcha.
here. Yeah, is what he's saying.
Yeah. So the idea is if you see 2 of these sharp angles, it's just trying to say that these are connected. He said he was gonna try not to do that to us on the test, with the idea that he's gonna draw it out like that and it being either up or down. Like he's not gonna do this on our test, is what he said during class. But if for whatever reason you see something funny like this one, just understand that if this is straight and this is bent, it's implying that there's a carbon right there. You only have one bend between the 2 of these, that's a carbon right
So
there.
what would you how would you classify that?
So then, we basically start counting back from our anomeric carbon. Our anomeric carbon for an aldose is always 1, and we count back from 2, 3, 4,
Yeah,
5,
that's a carbon.
6. So that's actually carbon number 6. So this would be an alpha, because it's going down, 1, 6. With the idea that we're looking at this and going, okay, well this is carbon 1, this is carbon 6, this one's pointing down, so it's an alpha, 1, 6.
So in his examples, he's counting 1, 2, 3, 4, 5, 6 over here. Why isn't he putting 6 on that?
I don't really know why I counted that way, but the idea is that he's just giving you the 6, how many members on that ring structure there are.
Like he's going 1, 2, 3, 4, 5, and he's putting 6 over here, not on that.
I don't really know, it doesn't really matter. Just know that if it's, because he's saying that it's a 6-member ring, so he's saying that this is spot 6.
Because technically, that's not a carbon.
Yeah, that's not a carbon, you're not
So
gonna bond
that's
with that
why.
oxygen, you're not gonna make any kind of bonds with that oxygen. So the idea is that when you're talking about this part of it, you're looking specifically at the carbons and what type of bonds the carbons are making. So for like this one, same thing, we said that this was an aldose, so we start with 1, it's going down, and this is how I expect him to draw it, if he was gonna draw stuff like on the test or whatever. and then so it would be alpha 1, and then we just have to count backwards for
1,
these
2,
carbons.
3, 4.
Oh yeah, so 1, 2, 3, 4. This is alpha 1, 4. Like that.
So the thing to the right of the O is always 1. The first one.
Yeah.
This one, if it's here, that's gonna be 1 if this is an aldose. If you see this little structure here sticking out, this is a
That's one.
ketose, and
Then
that's where it
that's
becomes 2. And
Okay.
this is 1, and this is 2, but only if that is there.
Only, okay.
If it's not there, yeah, this is 1.
So it's kind of like with this right here, you would literally make here, that's like 6.
Yeah.
Not here, because that,
Not here, because that
Mhm.
would five right there. And in terms of what's actually needed to bonds, 2, 3, and 4 are the most common places to bond, and occasionally 6. You're never gonna see anything bonded at 5, because it's already
Like
over
this,
bonded,
so
it's
it
got
would be
this
one.
here.
This would be 1, this would be 2. Versus if you don't have the ketose, this is always 1.
gotcha.
And yeah, in terms of, because it's always gonna be like 1 or 2 on the front end.
Like to talk about, like that's good enough to understand,
So in terms of like the front end, it's always gonna be 1 or 2 for what we're doing. And then it's usually gonna be 2, 3, 4, or 6. And really, I don't expect him to give us a 6. I don't really expect him to do that. Because
And then when all that
it's really hard to draw it out like this with that 6 carbon there without confusing people. So I really think he's gonna use 2, 3, and 4s for his like ones that he's drawing out, expecting us to be able to know like alpha or beta.
did he mention
That's
which I
what I'm
don't think
saying,
it would
like,
be here, but I
did
think
all
possibly
this, and, like,
sometimes there's 1-1. Is that even
There
possible?
is
So then
occasional
I'm
one,
working it
there is a
out.
possibility to have a 1-1, but it's again not super common because the way you have to draw out a 1-1 would be doesn't have to be a hexo, sure, but the idea is I'm gonna do it, make it an alpha 1-1. That would be so.
So you have to flip it.
The idea is this is 1, but at the same time, this is another 1. So that's a 1-1. But I don't think he's gonna do that for the test, because people are gonna see this and they're gonna be like, what the hell? You know, and they're not gonna understand like what he's trying to show there, because he didn't really talk about it.
Just globbed over it.
It's very, like someone, well, what it was is someone asked him, "You can have a 1-1." He was like, "Yeah, it's possible," but then he was like, "I'm not worried about it for you guys," or whatever, and he like moved on.
But that one would be alpha 1, 1.
So, but this would be what a 1-1 would look like.
Yeah.
In terms of this one, once again, I didn't draw any like ketose sugars initially, just because I was wanting to explain like how ketose sugars are different separately. But so this is 1, and then the idea is that this is 1, 2. So then this is going up.
Oh, oh.
So, because you always use your anomeric number 1 or your anomeric carbon to determine whether or not it's alpha or beta. So it's going up. So what is it?
Beta.
Or I'm sorry, beta 1,
Yeah.
2.
And then it's a beta 1, 2.
Okay.
And all that's talking about is this linkage right here, this glycosidic linkage. And that's all he'll have probably a few questions of this, where it's gonna be something real simple like this, where you have to figure out, based off of numbering your carbons, like what
Whether it's a
this is, whether or not it's like alpha, beta, whatever, and then you just have to be able to identify that if you see this here, that that's gonna be a keto sugar or whatever.
That's your.
And so then it's gonna be a 2 instead of a 1 or whatever, in terms of like labeling it. So yeah.
Okay.
And yeah, and like I said, you could say, okay, you know, take this specific sugar and turn it into a Fisher projection or whatever. And then so the idea is taking this and taking whatever direction my OH groups are or whatever, and taking that and converting it into the Fisher.
But he would have to give us all those.
But he'd have to give us those OH groups and stuff like that, which he'll have the actual structure, because I just don't
Oh,
have to
okay.
draw them, but he'll give you like the ones that you see in our slides where it's actually like a ring structure with all the OHs on it. So yeah.
That's what I'm scared of.
Yeah, but even then, like, yeah, I can't imagine that he would make it overly complicated when he did that. I think it's just knowing that if it's down, it's on the right, if it's up, it's on the left, these OH groups, which, like I said, I didn't remember that at all, like, and I didn't remember him saying that, but people have said that's what he said, and like, it's in our slides, so, I just wasn't paying attention. And so, like, you should be able to turn this Haywood projection into a Fisher projection using kind of the information that he's given us. It's a little bit more kind of complicated, but it's not terrible, it's not possible. Yeah. And my thing is just take, a few and just turn them back and forth and make sure you get comfortable doing just one or two. Definitely do glucose, because he said he wanted us to know what the structure of glucose looked like.
Oh.
He did say that in class. He was like, the only one that I expected to know the structure of is glucose.
And that's on,
Which glucose is on that slide of stuff.
Will you show us the glucose?
So the idea is that glucose looks like this. Your Fisher projection.
I don't think he.
glucose other is, what flag is that?
That's the side 8 or 9 on chapter 8. Oh,
Yeah, I just remember him saying, I'm not gonna make you learn all the sugars, but like glucose is important.
Oh, okay.
I don't think he like actually pointed it out for us, but.
2.5. So this is glucose. This is D-glucose specifically. With the idea that, the way I remember it, is that it's got one L in glucose, and it's next to the beginning of the name. So you've got one of these on the left, which is next to the one that makes it cyclic, or whatever, the G kind of looks like a circle, or whatever.
Oh, okay.
So in terms of knowing that there's just this one that's on the left, for D-glucose, this is D-glucose. If you have L-glucose, just know that everything is flipped from this.
Oh, it's different than this.
Okay. Sorry, I'm moving back.
Isn't that D-glucose? Oh shoot, it's on the top. Dang it. Okay, mess that up. Okay. See, even I don't know all these pretty well. So,
You've got a lot of weight on your shoulders, right?
too much crap.
It's okay.
Alright, so it's the other way. So it's this one, the second one, is the L. So just remember that it's L is number 2, so that's the second OH group. It's gonna be on the left. That'd be a good way to do it. I thought it was this one for some reason, but because I don't know everything. I've never claimed to know everything. So yeah.
Yay.
Okay. How are y'all feeling? That's about how it is, I think. Okay, I'm gonna hit stop.